I'm Shannon and welcome to Circuit Shorts. This is a series of lessons on basic engineering principles. Today we're going to cover power, voltage, current, and Ohm's law. These are principles that you're going to find in basic physics, electrical engineering, even around your own home. So let's get started. Let's start with a circuit. A circuit's just a collection of connected electrical devices. However, it's easiest to think about it in terms of something you're familiar with, like a flashlight. So what goes into a flashlight? You've got batteries for your power, a light bulb, and you also have some metal wiring and a switch to connect everything together. So when you press the switch, close the circuit and the light comes on. In the last example, we used some terms that were specific to a flashlight. But in general, these batteries are just a source of voltage. Voltage is a measure of the difference in electrical potential between 2 points. In this case, the positive and negative terminals of the batteries. We'll use V as the symbol for voltage. We mentioned current in the flashlight. This is just the flow of electrons through a circuit. We measure current in amperes or amps, and we'll use the symbol A to represent current. A light bulb is just a type of resistor. Something that inhibits the flow of current in a circuit. Resistance is measured in ohms, and we'll use the omega symbol to represent ohms. Finally, a flashlight has metal wires connecting the battery to the light bulb. We'll call this a conductor. Think of a conductor as something with zero resistance. We've been using the flashlight as our example, but there are also general terms to describe electrical circuits. On the left here we have a voltage source, and we're going to use V to label the voltage source. On the right we have a resistor, and we'll label that R for resistor. Finally, imagine the current flowing out of the positive side of our battery and going around to complete the circuit. We'll always label current with an I. When you're designing a circuit or a flashlight, you'll need to know how voltage, resistance, and current all relate to one another so you can pick the right components to create a successful product. So remember, we have our voltage here, we have our resistor here, and we have our current, I, flowing through. Now, Ohm's law is super helpful for this. It states that for any circuit, the voltage must be equal to the current times the resistor. So if I have a 9-volt battery here as part of our flashlight, and I have a 2 ohm light bulb giving us resistance in the flashlight, by Ohm's law then, the circuit must equal 4.5 amps. We can solve for that by saying 9V equals I times 2R. So this implies that our solution is 4.5 amps. Now, Ohm's law can also help us figure out constraints when we're building a product to make sure that it'll be successful. So for example, if we know that our circuit can't handle more than 10 amps, so I needs to be less than or equal to 10 amps. And let's say in this example we have a 20-volt power source. Then we're trying to figure out what the resistance needs to be. So in the flashlight, this would be the light bulb. So solving for R, we could use Ohm's law to say R needs to be greater than or equal to 20V over 10A. So this would imply, of course, that we would need a resistor of at least 2 ohms to be successful with this product. Now you might be thinking, I've never seen a 1 ohm light bulb or a light bulb ever that's been marked by its resistance in ohms. That's because light bulbs are sold based on the power that they consume in watts. So the power formula, the formula for power is P equals V times I. And of course, we know from Ohm's law that we can make a substitution here. So we can say P equals V, which by Ohm's law is I times R, times I. Or if we want to simplify that, that becomes P equals I squared times R. So if we used our last example, you might remember that we had a voltage equal to 20. We had a resistor equal to 2 ohms, and our current couldn't be any more than 10 amps. So again, if we apply the formula here, so P equals I squared R, our P is going to be equal to 10 squared times 2. So that would imply that our power would be 200 watts in this case, and so we know we need to buy a light bulb of 200 watts. Let's test our knowledge now. Given this simple circuit, how much current is traveling through the 10 ohm resistor? So let's again remember that we have our current I flowing through, and let's use Ohm's law to solve for I. Okay, the problem here was to solve for I, given the voltage and the resistance in the circuit. So if you apply Ohm's law, you would have found that V0 equals I times R1. So this would imply that 5 equals I times 10. That would translate to 0.5 amps. Now if you have trouble with this question, check out the Khan Academy video on Ohm's law. This is also a great lesson if you want to learn more about the details on the physics behind how circuits work. So today we've covered how a flashlight works in Ohm's law. Stay tuned next week for our lesson on series and parallel circuits. Thank you.